Alright, Assalamu alaikum jami'an. So today we inshallah will continue chapter 7, which is the last part of the slide, which is the elimination reaction and the two mechanisms, E1 and E2. Before I start actually this lecture, I would like to draw your attention to one correction, which is in slide number 11. Please, if you follow me, go to slide number 11. You will see in slide number 11 is this example, which is the SN2 reaction mechanism. The configuration actually of the starting material and the product has been written wrongly. So please correct it. The starting material, if you follow the rules, you will find that it is S configuration, and the product, if you follow the rules again, you will find it R. So just make this correction, please, before we start our lecture of today. So last time we have explained the SN1 and SN2 mechanism, and today we are going to talk about another competition reaction which is always there. So there is always a possibility of the other reaction, what we call it elimination reaction. As we have explained the elimination reaction, elimination it means starting from big molecule. This big molecule can eliminate part of it and simply becoming two smaller molecules. So what's the other competition reaction and how it looks like? The elimination reaction if we have this alkyl halide, for example CH2X attached to CHRH. Now here there is a possibility, if we allow it to react with the nucleophile, that the nucleophile may attack here, and then this alkyl halide, this halide may leave the reaction, right? So this is one possibility. So we will get the reaction which we have explained last time, which we have here. The nucleophile has displaced the X minus. So this mechanism or this reaction can be explained by SN1 or SN2, as we have discussed before, right? Now we are going now to discuss or to introduce a new reaction, and in this case, the nucleophile here, it may act as a base. And remember my word, any nucleophile is base and vice versa is true. Always. Any nucleophile is a base and any base is a nucleophile. It's just how we name it, it's just how the behavior. If the nucleophile attack a carbon, for example, this is nucleophilic behavior. But the base, as we have explained it before, the base is when this nucleophile attack or abstract a hydrogen. So this abstraction or attacking of a hydrogen, this is what we call it basic behavior. So in this case, if this nucleophile behave as a base and attack this hydrogen and took it as H+, then the bonding electrons which was made between this carbon and this hydrogen, again here, remember this carbon is the carbon adjacent to the carbon which bonded to the halogen. And then the bonding electrons will make a double bond here and the X will leave. So this is the alternative reaction. This is the competition reaction which is always accompanied or which is always there is a possibility to occur or to take place. What we call it elimination reaction. Now, the elimination reaction then, it will be the product then, if the nucleophile at the base, then the product will be alkene, as you can see, RCH double bond CH2 plus HX. Here, see, in this case, we will have elimination reaction if the nucleophile act or behave as a base, and then we will have alkene. It's very important to remember that in order for the alkene or elimination to have a chance, we must have this arrangement of the atoms. We must have a hydrogen adjacent to the next carbon, which is to the carbon which is attached to the halogen. So in other words, carbon attached to the halogen, the next carbon there must be a hydrogen. For any reason, if this carbon is not connected to any hydrogen, then definitely there is no chance for elimination reaction to take place. Is that clear? So this requirement is extremely important for the elimination to take place, that there must be a hydrogen at least attached to the carbon which is next to the carbon connected or bonded to the halogen. Is that clear? Is there any question about it before just moving to the next slide? I'm waiting for some response. Is this clear? Iman, what you don't understand in here? It's now clear? Okay, all right, okay. Now, so this is about, so this reaction is always possible. There is always a possibility of this reaction once we have a nucleophile reacting with the alkyl halide. Now, before talking about the general requirement or simply the general table which enables us to determine what would be the product of the reaction, then let's first introduce a rule which is always associated with the elimination reaction, what we call it the side-shift rule. In that side-shift rule, whenever there is a chance for elimination to take place, the major product will be the more substituted alkene. We may write it or we may draw it, we may write it in different ways. Side-shift rule is that the alkene, whenever we have different possibilities, the alkene produced is the one which is more substituted. In other words, this is a double bond, right? The double bond, carbon double bond carbon, is connected, or these two carbons are connected here to 4 bonds, right? Now here, as the number of the alkyl groups increase, simply the stability of the alkene increases. In other words, the R here are very much higher stability, or they are more stable compared to if we have, for example, the alkene attached to 3 substituted, and the 3 substituted is more stable compared to 2 substituted, and so on and so forth. Do you follow me? So this is simply that side-shift rule. As the number of the alkyl group attached to the carbons or the carbon double bond carbon system, then the stability will increase. So in this example here, as you can see it, I'm just moving, 2, 4, 5. All right, in this example here, you have it in the slide. If you allow 2 bromopentane, 1, 2, 3, 4, 5, 2 bromopentane to react with this, which is a strong base, in this case, CH3O minus and A plus. Now, as we will see in the next slide, you will see in the next slide very easy here. But here, this will act or behave as a base, most likely, and we'll explain in the next slide why. Now, in this case here, the base here, this reaction will have 2 chances or 2 possibilities to abstract a hydrogen. Either it may abstract this hydrogen at this carbon, or may abstract this hydrogen. So these are the 2 possibilities. If this base takes this hydrogen, that means the double bond will become between these two carbons. If the base abstracted this hydrogen, then the double bond it will be at position 1, as it is explained in your slide here. Of course, as we said in here, the more substituted the alkene, the more stable it is, and thus most likely to be the more major yield. So in this case, if we want to just write the major product, it will be this one, only this one. So this will be major product according to Zaitsev rule. Because simply, as you can see here, this alkene, which is the major in your slide, as you can see it, it is connected to two alkyl groups. Is it more clear now, Aziza? You will see it actually in the board. Actually, on the board, similar to the slide what you have it in the presentation, but you can see the video will be more clear actually. But now, is it more clear, Aziza? The voice and the board. All right. But the most important thing to understand what I said in this slide, which is talking about the Zaitsev rule, whenever we have a chance to make elimination reaction, whenever there is more possibilities, the alkene which will be always produced in major yield will be the one which is more substituted. In other words, the alkene which is attached or connected to more alkyl groups, as you have it, as you can see it in the slide. Now the question is, we must determine then what would be the reaction then. By the way, the elimination reaction, we are not going to discuss the mechanism, so forget the mechanisms. You are required to know what would be the product, if it is SN1 or SN2, or what if it is elimination, if it is E1 or E2, as we will explain in the last slide. So for the last slide, as you can see it, here we said if the nucleophile, if alkyl halide Rx reacted with the nucleophile, there is two possibilities. If it reacted with the nucleophile, or it reacted with a base, or the behavior of the nucleophile was a base. So we will get, if it is a nucleophilic behavior, it will be displacement or substitution of the halogen. But if it is reacting or behaving as a base, then we will get elimination product. Do you follow me? Now the question is, generally speaking, as we said, every nucleophile is a base and every base is a nucleophile. The question is how to determine if this is, or this species here will behave as a nucleophile or as a base. As you can see it in the slide, whenever we have the nucleophile, if the nucleophile is carrying a negative charge on large size, such as, give me some atoms which you are going to deal with in this course, only sulfur, for example, or iodine. These are very big size atoms, and thus, therefore, as you can imagine, this negative charge supposed to be stabilized, and therefore the nucleophilic behavior will be higher. So the nucleophilic behavior, generally speaking, if the negative charge on a large size, or it is stabilized via resonance. And the only example I gave you, for example, but you can guess any other examples. If we have this acetate, if the acetate here, as you can see, the negative charge in oxygen, but this example here, or this nucleophile, is stabilized by resonance structures, because we may draw the resonance structure for this nucleophilic species, and therefore we may have this double bond. Oh, sorry. Do you follow me? So these two examples telling us that most likely any species which have a negative charge on large size atoms such as sulfur or iodine, or any species which has resonance stabilization such as the acetate, most likely the behavior will be nucleophile. In other words, most likely the product will be either SN1 or a product of substitution, but the substitution, as we said, it's either to be SN1 or SN2. Is that clear for the nucleophilic behavior? So in order to have or to guess or to predict the nucleophilic behavior of the species, these are the two requirements for the nucleophilic behavior of the species. Is that clear? Is there any question about it? Any response, please? Wonderful. All right. So, on the other hand, if the negative charge here is not stabilized via resonance, or in other words, it is localized, or it is on a small atom, then definitely will be the or most likely to be elimination reaction behavior. So, for the base behavior, if the negative charge is on a small atom, such as, this is of course general talking here, but we are not going to make it generalized forever. For the level of this course, most likely the small atoms, what we are talking about, are oxygen or nitrogen, for example. These are actually, in this case, most likely this will be basic behavior, and of course it is not stabilized. In other words, there is no resonance structures which we can draw for these atoms. Then definitely, most likely, the basic behavior will be major in this case, and therefore we should expect elimination reaction to take place. Is that clear? So this is the general requirement regarding the nucleophile here, the nucleophilic behavior. If it is nucleophile, most likely nucleophilic substitution. If it is basic, then most likely elimination reaction. Any question so far? Is there any question? Perfect. So you can see the table here. So in this table here, the other factor which is extremely important, of course, in order to enable us to determine what would be the product and what would be the mechanism, is the nature of the alkyl halide. Now, as you can see in the table, we always classify the alkyl halide based on its classification like primary, secondary, or tertiary. So the primary will behave a certain way, different than the secondary, different than the tertiary. So as you can see it in the table there, most likely a primary alkyl halide, primary alkyl halides, they always behave as N2 reaction mechanism. Most likely, in most of the cases, except a very strong base. So, regardless of the nucleophile here, if we have primary alkyl halide and any nucleophile, most likely it will be substitution reaction via SN2 reaction mechanism. But in very rare cases, if we have very strong base, and most likely the strong base we will refer to very special base here, which we call it tertiary butoxide. And this you can see here, the tertiary butoxide, this space here, we have a negative charge connected to oxygen, and this oxygen is highly steric one, and also it is highly unstable. Then therefore the reaction in this case will proceed toward elimination reaction, and the mechanism of the elimination reaction will be then E2 reaction mechanism. So these are the very simple type of alkyl halides. Primary, very straightforward, always SN2, except when we use this base, اللي هو tertiary butoxide. Do you follow me? Now, what about the methyl alkyl halide? طبعا methyl alkyl halide, remember, the methyl alkyl halide is still even less strictly hindered alkyl halide than the primary. What about it? What do you think? Is there any chance for elimination reaction to take place? I need your answer, please. What do you think about the methyl alkyl halide? اللي هو CH3X. Is there any chance for CH3X to undergo elimination reaction? By any means. Make it like interactive lecture, guys. عادي يعني. Just interact. Why, for example, if I may ask, Salama, for example, why do you think there is no chance for methyl alkyl halide to undergo elimination reaction? Absolutely, that's absolutely true. Because there is no other carbon connected to this carbon in order to have elimination reaction, and therefore methyl alkyl halide always SN2, regardless of the nucleophile which we are using, guys. Is that clear so far? In order just to make it as simple as possible. Exactly, thank you, Rashid. Exactly, that's true. Always, in order to have elimination, we need another carbon which is connected to a hydrogen in order to have elimination reaction. So as you can see, these are two simple ways of the alkyl halides. The other part, which is again simple, lower tertiary. The tertiary alkyl halide most likely to undergo by SN1, most likely in most of the cases, if the SN1, if it is, or E1 actually, SN1 or E1, if it is neutral nucleophile. If it is the nucleophile, if it is negatively charged one, then definitely will be E2. These are the two possible ways for the tertiary alkyl halide to react. Only two ways. If the nucleophile is neutral, most likely will be a combination or a mixture of both products, SN1 product or E1 product. If it is negatively charged ion, then the only major product will be E2. So any negatively charged atom, if it reacts with the tertiary alkyl halide, then it will be E2. And as you can see, the secondary alkyl halide will be like a mixture of all, but you can see it here. It will be SN2 favored if it has more nucleophilic behavior. If it is more basic behavior, then it will proceed most likely toward A2. So I hope this table will be easy, and I'm pretty sure it will be very much easy. Just try your assignment. Try to imply these rules, these general rules, to know what would be the product in your assignment. I'm pretty sure you can follow it up easy, and then you will get only one product in each of the cases. Is that clear so far for this slide? Any questions so far? Rashid, is this yes for, is that clear or there is a question? That's a very good question actually. I received a question from Al-Hinai that why, generally speaking, the more the substituted alkene is the major product. But actually this question, generally speaking, a little bit beyond the scope of this course. So for the time being, I will skip this question but if you wish, I can send you more details about this by email. For the time being, you are not required to explain this trend of behavior or this behavior or that types of rule. All what you are required to do is to recognize it. The alkene, which is more stable, more substituted, will be the major alkene, the more major alkene. Is that clear, Al-Hinai? Perfect. All right. For this, it's enough for today. Inshallah, I hope now you understand everything regarding chapter 7, and please do your assignment for the chapter 7 until the end of this week, until Thursday, and then next week, inshallah, we will start a new chapter. So if there is no further question, I would like to thank you all for attending the lecture, and inshallah, we'll be in touch. Any question before leaving?